take it down. Profits 75, 40, 80, 30, 25, 45, 35. These are the profits, and the weights 7, 3, 9, 2, 3, 4, 3. So these are the weights we have. These are the profits and these are the weights. And how many objects we have? 1, 2, 3, 4, 5, 6, 7. 7 objects we have. I hope the board is visible to you. Is it visible? Now the first step we have to calculate is P by W. So calculate P by W. Calculate P by W. So 75 by 7. 10.71. See, already I have calculated. If the answer is wrong, you just give me the answer. Next is 13.3. 40 by 3 is 13.3. Next, 80 by 9, 8.8. 30 by 2, 15. 25 by 3, 8.33. 45 by 4, 11.25. 35 by 3, 11.66. So these are the profits per unit weight what we have. Now what is our condition here? Our condition is the profits per unit weight, whatever we are considering, it should be in the descending order. So I am rewriting this table once again. So here, I am rewriting here. Now in this, which is the maximum profit per unit weight we have is 15. So first what I am doing is I am writing profit per unit weight. I am just taking the new table now. Why we are taking a new table? Because we have an assumption that it should be in the descending order. So in this, which is a maximum, we have 15 is maximum. So I'll write 15 here. And I'll write the profit and what is the weight, and I'll write the object also. Object. So what is the profit for 15? The profit for 15 is 30 and the weight is 2. And what is the object? Object is 4. Now similarly the other one. So the 4 we have completed. What is the next maximum we have? The next maximum we have is 13.3. And what is the profit we have? 40. And what is the weight? 3. And what is the object number? 2. Object number 2. So object 2 we have completed. Which is next maximum? 11.66. 11.66 is maximum. And profit is 35. 3. And the object is 7. Object is 7. So 7 we have completed. Now the next maximum we have is 11.25. 11.25 we have. Now what is the profit? 45, 4, and the object is 6. Object is 6. So 6 we have completed. Now next, which is the next maximum? 10.71. 10.71 is maximum. Profit is 75. Weight is 7. And the object is 1. Object is 1. Now, what is the next maximum? Next maximum is 8.8. 8.8. 80 is a profit, 9, and the object is 3. So 3 we have completed. Now the next one we have is 8.33, 25, 3, and what is the object number? Object number is 5. So in this way we have rearranged the table now. All of you have completed the table rearranging. If you are finished, now let us see the algorithm now. The first consideration in the knapsack algorithm is it should be in the descending order. Which should be in the descending order? Profits per unit weight should be in the descending order. So according to that, we have rearranged. Okay, now the next, what is the next thing you have? You have the for loop here. What is the thing you have for I equal to 1 to n? That means for all the objects, we have to take x is nothing but a solution vector. So for all the objects, the solution vector, you have to take it as 0 and u equal to n. What is our knapsack capacity? I think knapsack capacity I did not given you. Okay, take the knapsack capacity as 20. M equal to 20 you take. So I'm just erasing this. We will start this tracing. So what is happening now? All the values, all the x values is 0. All the x values is 0. What is I value? I is from 1 to 7. That means x1 is 0, x2 is 0, so on, x7 is 0. Initially, we are taking that. And what is u? U equal to 20. Now again the for loop is starting here. So first time I equal to 1. I equal to 1. What we have to do? If W of 1 is greater than U, then you have to break. So first, W of 1 greater than U. What is our W of 1? W of 1 means this table only we have to take. This will be our first object now. Okay, so what is our W of 1? 2. Greater than 20. False. 2 greater than 20 is false. Now, if condition is not satisfied, now next what we have taken here, x of 1 equal to 1. X of 1. That means this items here, I just write down the index here. 1, 2, 3, 4, 5, 6, 7. So, x of 1 is 1. Now, next. So, this complete object, about the weight 2 we have assigned now. So, we have to reduce the knapsack capacity. So, u equal to u minus w of 1. U equal to u minus w of 1. What is our u? 20 minus w of 1. That is 2. So, still we have 18 in the knapsack. Still we have empty spaces 18. So, that is first iteration we have completed. First iteration we have completed. Now coming to the next one. We are starting with the second iteration. So second iteration, W of 2 greater than U. What is our W of 2 now? W of 2 is 3. Greater than. What is our U? U is 18. So 3 greater than 18. false. 3 greater than 18 is false. Now again, x of 2 equal to 1. Again, you are taking the complete object. So x of 2 equal to 1. If it is completed, I'll just erase this part only. And again, since we have considered the complete object, now u equal to u minus w of I. What is our u? 18. Now how much you have allocated? 3 you have allocated. So u is becoming 15 now. U is becoming 15. That is the second iteration. Now I equal to 3. I equal to 3. So W of 3 greater than U. What is our W of 3? It is 3 greater than 15. False. Now again, x of 3 equal to 1. So this also we are considering completely now. X of 3 equal to 1. Now what will be our u value? U was previously, u was how much? 15 minus how much? 3. 12. So our new u value is 12 now. Is it correct? Are you getting the same answer, all of you? The u is 12. Yeah. Now the third iteration we have completed. Now I equal to 4. So W of 4 greater than U. What is our W of 4? It is 4. What is our U? 12. So false. 4 greater than 12 is false. Now x of 4 equal to 1. You are selecting complete item. Now what is U? Before it was 12. Now you have selected the fourth item. So 12 minus 4. 8. Now U is 8. So that is for the fourth iteration. Now for the fifth iteration, I equal to 5. I equal to 5. W of 5 greater than U. What is our W of 5? 7 greater than how much we have? 8. False. Previous U was 8. So 7 greater than 8 is false. And x of 5 equal to 1. X of 5 equal to 1. Now what is our U? What is our U here? 8 minus 7. So you are getting as 1 now. U is 1. So that is the fifth iteration. Now I equal to 6. W of 6 greater than U. What is our W of 6? W of 6 is 9. 9 greater than, what is our U? 1. So 9 greater than 1 is true. So since it is true, what we have to do? Break. From the for loop, you are breaking now. So break. So the for loop is completed now, since we are coming out of the for loop. Now what you have here? Now you are coming out of the for loop. Now you have an outside, you have one condition. What is the condition you have? I is less than or equal to n. I is less than or equal to n. I'm just erasing here. I is less than or equal to n. We are coming out of the for loop now. So now you have to check a condition. I is less than or equal to n. What is our I value? 6. What is our n value? 7. Total number of objects are 7. So it is true. So since it is true, now what we have to do now? x of I equal to, x of I means I is 6 here. X of 6 is equal to u by w of I. What is our u? U is remaining is 1. W of I. W of I means x of 6. What is x of 6 we have? W of 6. What is our W of 6? 9. 9. That's all. You will be coming out of the program. We don't have the value for 7. All of you got the same answer for x of 6? It is 1 by 9. Okay, now let us write the final table now. I'm just erasing all this. If you have completed, so write the table once again. Now what are the x values we got? For the object 4, we got 1. This is 1, 1, 1, 1. And for x6, we got 1 by 9. x6, 1 by 9 we got. We did not select this, the last object at all. So this is becoming 0. This is becoming 0. These are the x values. This is for the object 4, object 2, object 7, object 6, object 1, object 3, object 5. Now let us write the final solution. x1, x2, x3, x4, x5, x6, x7 equal to x1. That means object 1. Where do we have object 1? Here we have object 1. What is object 1 value here? 1. Object 2. So here we have object 2, 1. x3. Where is our object 3? Yeah, this is our object 3. So it is 1 by 9. Object 3 is 1 by 9. x4. Where is our x4? This is our x4. It is 1. x5. The object 5 we did not select. So it is 0. x6. x6 is it is 1. x7, 1. So these are our x values. All of you got the same answer? 1, 2, 3, 4, 5, 6, 7. And what is our constraints? What are our constraints? 2 constraints we have. We have 2 constraints. What are the 2 constraints? The first constraint is 0 less than or equal to xi less than or equal to 1. All the x values should be between 0 and 1. All the x values are between 0 and 1. So this constraint is satisfied. What is another constraint? The another constraint we have is sigma wi xi should be less than or equal to m. Sigma wi xi less than or equal to m. Yeah, check it now. I want this value. Wi xi. Multiply and give me the value. W1 x1 plus W2 x2 plus so on. What's the answer? Just multiply these two. 2 into 1 plus 3 into 1 plus 3 into 1 plus 4 into 1. Yeah, it is 20. Okay. So 20 less than or equal to 20. True. True. So the second constraint is also satisfied. Now, what is our objective function? What is our objective function? Objective function is maximize z equal to sigma pixi. Sigma pixi. So multiply 30 into 1 p1 x. P and x multiply and give the answer. Into 1 plus 40 into 1 plus 35 into 1, 45 into 1 plus 75 into 1 plus 80 into 1 by 9, 25 into 0. Taking lot of time for multiplication and addition. Are you there, all of you? It's 233.88. Okay, 233.88. Whether all of you got the same answer? 233.88. So that is the maximum profit of this knapsack problem. So now we will see the time complexity of this knapsack. So I hope all of you have completed. All of you have completed? Whether all of you are getting the same answer? 233.88. Okay. Now take the heading now, time complexity. Let us see how to find out the time complexity now. So how to find out the time complexity for the knapsack problem here is, so thing here is, in this knapsack algorithm, what is the first thing you are doing? The first thing you are doing is we are calculating P by W. For each and every object, we are calculating profit per unit weight. For each and every object, we are finding out. If you have n objects, for n objects, you are finding out. So the first step in the knapsack problem we are doing here is we are calculating profit per unit weight for all n objects. So to do this, for finding out the profit per unit weight, the time complexity is big O of n. For n objects you are finding out, so it is big O of n. That is the first step what we are doing. Now coming to the second step. Second step, what we are doing here is, after calculating profit per unit weight, what we are doing here is we are arranging in the descending order. We are arranging in the descending order. So arranging in the descending order, the meaning is we are going with the sorting. We have to go with the sorting. So we have sorted and we have arranged the elements in the, which one? Descending order. So the best algorithm, if you take, the quick sort is the best algorithm. So any best algorithm if you take for the sorting, the complexity you have is big O of n log n. Big O of n log n. These are the two major things what you are doing in this algorithm. Remaining we are finding out which objects, all that are also considered, but these are the two major things what we are doing in the algorithm. The first one is profit per unit weight we are calculating. For this, it is big O of n. And the next one, what we are doing is after calculating profit per unit weight, we are arranging in the descending order. That means we are going with the sorting. So sorting, the best algorithm, if you take the quick sort complexity is big O of n log n. Now, the total time complexity, these two you add it now. It is big O of n plus big O of n log n. N log n. So according to the properties of complexity, the lower order terms will be neglected. So the lower order term is n. This n will be neglected. Finally, you will be having is n log n. N log n. So n log n is the time complexity for the knapsack problem. What is the time complexity for the knapsack problem now? N log n. We don't have any derivation. Just how much it is for profit per unit weight, how much it is taking for the sorting. In that we are saying which is maximum, and that is the time complexity. Please check it all of you once. Any doubts you have? If it's completed, say S in the chat window. So we have completed the knapsack problem. So total 3 cases we have seen in the knapsack algorithm we have seen, and we have also completed the complexity. We have seen the example with the maximum profit, minimum weight, and the third one is maximum profit per unit weight. All the 3 cases we have completed. So with that, knapsack is completed. Now we move to the next topic now. Shall we move to the next topic? So the next topic is job sequencing with deadlines. The next topic, job sequencing with deadlines. All of you take the heading. We will start this with an example, then it will be clear for you. So take the example, n equal to 4, P1, P2, P3, P4 equal to 25, 45, 16, 60. And D1, D2, D3, D4 equal to 3, 2, 3, 2. So this is what given to us. So first we will try to understand what is the meaning of this actually. What is given and what we have to find, we have to see here. What is our topic name? Job sequencing with deadlines. Now what is given here is n equal to 4. N equal to 4 is nothing but 4 jobs. 4 jobs are given, and if you complete the first job, this P1, P2, P3, P4 are the profits. The profits are given. if you complete the first job, we will be getting a profit of 25 rupees. Like I'll take the units as rupees here. And if you complete the second job, we will be getting the profit is 45 rupees. Third job, 16 rupees. Fourth job, 60 rupees. In this way, the profits are given. Now, the another thing which is given is D1, D2, D3, D4. These are the deadlines. Deadlines are given to us. So, D1, D2. So, to complete the first job, the deadline given is 3. 2, the second, 3 for the third, and 4th for the second job. So, 4, yeah, the fourth deadline is 2 here. So, these are the deadlines which are given. And here, we will take some assumptions, and I hope up to here it is clear for you. 3 things are given: the number of jobs, profits, and the next one is deadlines are given. So, here we have to go with a few assumptions. What are the few assumptions here is, let us assume that we have only one machine. We have only one machine is available. Only one machine is available. These are the assumptions what we have to take. One machine is available with us, and at a time you can do only one job. What are the assumptions? The first assumption is one machine. And the second assumption we are doing here is at a time only one job. At a time only one job. This is the second assumption. And the third assumption is any job will take only 1 unit of time. Any job will take 1 unit of time to complete. Any job will take 1 unit of time to complete. These are the 3 assumptions what we are taking here. Only one machine is available. At a time, only one job only we can do. That means multi-processing is not possible here. And what is another condition here? Only any job, it will take 1 unit of time. Like 1 unit means 1 hour. Let us assume any job you take, it will be taking only 1 hour of time to complete. Okay. See, this completion and the deadlines are different. Any job, same time it will take to complete. Okay, these are the 3 assumptions what we are taking here. Take down all the 3 assumptions. See, this is little tricky, so please listen carefully and important. One machine, at a time only one job, and any job will be completed in 1 unit of time. 1 unit means here let us assume hour, 1 hour or 1 day, anything. 1 unit of time. Have you taken, all of you? If you have taken, I'll start now. Okay, I'm getting the answers yes here. So these are the 3 assumptions what we are considering here. Okay, shall we start now? So only one machine is available, as already I said, and these are the deadlines which are given here. Now I'll just come to these deadlines once again. What is the meaning of this? As I said, each and every job will be taking 1 unit of time. Now, what is the meaning of this 3, 2, 3, 2? The meaning is the first job, like how much you have, if you observe in these deadlines, the maximum deadline you have is 3. The maximum deadline you have is 3. What I said, each job will take 1 unit of time. So I'll take 0 to 1. This is 1 unit of time. 1 to 2 is another unit of time we have, and 2 to 3 is the another unit of time here. This way, any job you take, that will be completed within 1 unit of time. So 0 to 1 is 1 slot we have. 1 to 2 is one more slot we have, and 2 to 3 is another slot we have. Now, for example, if you take the first job, what is the first job deadline it is given? The first job deadline is given is 3. The meaning is we can do the first job in the first unit of time, or we can do in the second unit of time, or we can do in the third unit of time here. That means the first job can wait up to this time. The first job can wait up to 3 hours. Third hour it can wait. Okay, any job, it will take only 1 unit of time, I said. What is the deadline given? The deadline given is 3. The meaning here is the first job can wait up to the third hour. Third hour local IPOL. Before third hour, it should be completed, the first job. That is the meaning of 3. Okay, like I'll just, for example, I'll take 1 also. For example, if I take 1. Now, what is the second job? The second job deadline is 1. The second job deadline is 1. The meaning is this also will take 1 unit of time only. But what is the deadline? It should be completed within the first hour. And only the chance we have is only within the first hour only we can complete the first job. So that is what is the meaning of deadlines here. So what is given here? 2. So the second job should be completed within 2 units of time. This is within 3 units. Within third hour it should be completed. So it will be waiting. It can wait. So first hour it can wait. Second hour also it can wait. But it should be completed within the third hour. And the fourth job, it can wait for the first hour. But it should be completed within the second hour. You got some idea here? While we start the example, it will be more clear. Shall we start the example? If it is not clear, okay, no problem. We'll start with the example and I'll explain you again. Excuse me. Shall we start the example? So here, let us take the table here. So in the table, we are taking is a serial number. The 4 columns we will take. The first is a serial number. The second column is feasible solution. The next one, processing sequence. And the fourth column, maximum profit. These are the 4 columns. Now I'll start with the first one. See, as already I said, this is a little tricky. Please try to follow it carefully. Now the feasible solution we have to find out. How to find out here is totally we have 4 jobs. 4 jobs we have. We should try with different possible combinations we have to try such that we get the profit is maximum. We should try with the possible combinations, the job such that we should get the maximum profit here. Now, what is the deadline we have? The maximum deadline you have is 3. That means how many slots you will be having if it is 3? How many slots? We will be having 3 slots. We will be having 3 slots because the maximum deadline is 3 here. 0 to 1 is 1 slot. 1 to 2 is 1 slot. 2 to 3 is another slot. See, please see carefully here. We should find out the feasible solutions. How to find out is with the different combinations of jobs we should find out. So how to do with the different combinations is, first we should know how many slots we will be having. How many slots we will be having is, it depends on the It depends on the maximum deadline. What is the maximum deadline you have? 3. So since you have maximum deadline 3, that means you will be having 3 slots. So the 3 slots are 0 to 1 is 1 slot, 1 to 2 is another slot, 2 to 3 is the another slot. If it is clear, please say yes, then I'll proceed further. I am not able to understand whether you are following or not. Is the number of slots clear? So 3 slots we have, right? Now, since we have 3 slots, the meaning here is maximum 3 jobs we can do. 3 slots we have. Total number of jobs given are 4. But the maximum deadline is 3. So since the maximum deadline is 3, we will be having only 3 slots. The meaning is maximum how many jobs we can do is only 3 maximum jobs we can do. Maximum 3 jobs we can do. So now we will write different possible combinations and let us see here. Now what I'll do is, I'll take the first combination. We have to take different combinations here. So 1, 2. 1, 2. What is the meaning of this is, I'm selecting the first job and the second job. The meaning of the second column, feasible solution, is, as I said, we have to go with the different possible combinations. So how to go with the different possible combinations is, I'm doing with 1, 2. Similarly, 1, 3, 1, 4. So 1 with different possible combinations. 2 with different possible combinations. 3 with. So in that way, for all possible combinations, we have to find. So first, we started with 1, 2. That is the first one, feasible solution. Now, the processing sequence we have to do. If you are selecting 1, 2, in which sequence we have to process? Is this clear? I'm selecting 1, 2. Now, if I've selected 1, 2, the next thing what I have to do is, I should find out in which order I have to do. So, in which order I have to do? I will write down here. In which order is, okay, I'll just show you here. What is the first deadline? First job deadline you have is 3. And what is the second job deadline? 2. The second job deadline is 2. Now, in this, which is smaller, which should be completed first? First job deadline 3. The meaning is, the first job can wait for 3 hours. The second job deadline is 2. That means the second job can wait only up to 2 hours. In this 2, which is minimum, the second is minimum. The meaning is, first, the second job should be completed, then the first job should be done. First, the second job should be completed because the deadline of the second job is less than the deadline of the first job. So, the processing sequence for this will be, it should be 2, 1. The processing sequence should be 2, 1. Is this clear? If it is not clear, I'll explain you again. Please check it once. First, I have selected 1, 2. Now what I'm doing? I'm going the processing sequence. The meaning of processing sequence is which job should be done first. Now, which job should be done first? How you'll find out? Based on the deadline. The first job deadline is 3 and the second job deadline is 2. From these two, it is very clear which should be done first, which is having deadline early. Early deadline is the second job. So, second job should be completed first, then the first job can be done. This is the processing sequence we have. Now, coming to the next one, the fourth column, maximum profit. So, what is the profit you have? These two we have selected. First two we have selected. So, that means these two. So, 25 plus 45. 25 plus 45. The profit is 70. The profit is 70. So I think it's almost 10 o'clock. I'll just stop for today. Any doubts? See, I know it's difficult, but if you listen, if you get the concept, it will be easy for you. At least little idea you got now. Okay. Yeah, okay. So tomorrow, once again, I'll start this and I'll explain you.